So good afternoon. We were just sharing a few of the stories that you don't know because you were not even born. Yeah? And there were no pandas, and there were no Visual Studio Code. There was no Jupyter notebooks. There was nothing. Anyway, so we are very happy that Binjamin is again with us, and I see lots of ha-ha-has in the chat. Yeah, that was reality. Yeah? Binjamin, so please keep spoiling our participants with the fancy tools that we have today, that we were only dreaming of when I started. Yeah? And you know, just to finish those anecdotes, I'm very happy that I'm living in the era of ChatGPT, because I'm very happy that I lived that. So that's another big change. Yeah.
No, thanks, Prof. I think we should have a mini school just on your experiences and anecdotes. I think a lot of people will appreciate that.
Yes. You know, the first PC that I bought out of my hard-earned money as a PhD student didn't even have a hard drive because that was too expensive. Yeah. Wow. And it had 2 floppy disk drives. Yeah? And if you wanted to compile code in Fortran, Fortran was on 4 or 5 floppy disks. So the compiler was telling you, push in disk 2, remove disk 1, put in disk 3. It was just terrible. Yeah. But anyway, that's history. Yeah.
I still remember, just to add context, I mean, I'm not that old, but I still remember installing Windows, I think 3.1 with like 30 floppy disks.
Yes. No, that I lived through. And a postdoc in our group at that time, he was the first one who bought the same PC, with a 20 megabyte hard drive. Yeah. And all of us students went to his home to see it because we couldn't believe that someone could afford a 20 megabyte hard drive. And now every watch has probably 100 times more. Yeah. Anyway. Yeah.
No, thanks so much.
Okay, there's somebody else who remembers the multiple floppy drive days. Excellent. Yeah. Excellent. Yeah. So you know what I'm talking about. Yeah. Excellent. Yeah. Good. Binjamin, sorry, I didn't want to steal your show. It's just that for some reason, remember how we started this discussion.
No, these stories are great stuff.
Yeah,
right, so let's carry on.
Yeah, no, right, please, over to you. Yeah, it's your show. I will keep quiet now. Yeah.
All right, so welcome everyone. So this is lecture 3. We're now mastering Pandas mini-school. So based on some feedback, well, a lot of feedback I got from the forums and just on the chat, we're going to focus a little bit on different things than the prescribed lecture 3 guidelines. We will cover certain things, but the main topics I'll mention shortly. Doesn't have video anymore. Okay, so let's look at this over here. Okay, so just a bit of what of advice, I guess. This is by John Creswell. Says networking is the lifeblood of research. It allows us to share ideas, find collaborators, and create new knowledge. And just as a I studied my undergrad engineering, and then I worked for about 5 years and did my master's at UCT. And I missed having the resources of a university, speaking to lecturers, having a library, and the massive, network of resources you have at a university. So it's very important, like whatever field or department you're in, make sure to some degree all your lecturers and have at least some email contact with them, or even people in different departments, because you never know who you might need help from or collaborate in one day. So networking, like actually any field or any discipline, even industry, is a lifeblood of how things operate. So make sure you know everyone, and have some kind of contact with them, because you never know in the future how you might collaborate or work together. So take that into consideration. All right, so bit of agenda today. So we're going to look at some admin items. I got a lot of questions and queries, so I'm going to actually answer those because it kind of covers a lot of the content that I planned for the mini school. So we're going to use a practical approach to kind of answer those questions and cover the content at the same time. And then we're going to look at time series analysis, which was supposed to be done last week, but I just pushed it to this week just out of the demand from what everybody's requesting. Yeah, so a bit of admin. We'll go back. So just remember, all the code and lessons is on the GitHub repo. So this is the GitHub repo. Quite a few more people have forked it. So lecture 3, all the notes and code and everything that you need is all here. So you can always get it. And again, there's a discussions group. So if you want to reach me after the lesson today, you can. You can go to lecture 3 or whichever one and have a discussion here. So give you the URL, put in the Zoom chat. So you have it there. Yeah, and that's a discussions one. Like I'll put the discussions one there shortly too. If you have any questions or comments. I know Tajuddin has also added some useful EDA libraries as well. So you can have a look at that too. Let me put it in the chat. So that's a discussions. You can have a look at that if you have questions or comments after the lecture. There's a form that I'd like everyone to fill in, but I'll do that like at the halfway point. Okay, so that's it from the slides. Let's get on to some of the questions that we had. Okay, so the first one is actually GitHub discussion. So this was, I think it was lecture 2. I had a question here. This is from Jane, I think. So Jane mentions error catching. For example, doing in join, the client makes some mistakes with every batch of data. Instead of going through it line by line, you ignore the error right over it. Is something that we can cover in this course? Well, not necessarily. As I said, I need a bit more context, but generally for errors that you kind of expecting, first try and it might give you data that is problematic and can lead to further problems down the road. So firstly, try and fix the error, communicate with the client, whoever it is, to resolve it. You can implement some error handling as well to catch the errors. So I guess one good way is try and accept block. You can add that to your code, right? So that's some things you can do. But again, I need a bit more examples or context to really answer this. Okay, so a few other questions just to start things. So web scraping, somebody asked about web scraping. So we don't really cover web scraping in this course. You can obviously use there are libraries that are specifically catered for it, like Beautiful Soup, for example, is a library, and there's a lot of tutorials on it, but we don't really cover it here. Obviously, whatever data you get, you can obviously read it in to a Pandas DataFrame. Like if, for example, if reading in an HTML file, you can read that in and filter and sort it. Like one question was making mixed plots like distribution. So this is a visualization question. So how do you have like 2 plots on the same figure? So I have a brief example I can show you. So again, working with an iris dataset, what you need to use is this this function called subplots. So subplots allows you to have multiple plots on a single figure. So you can have as many as you want. If you like, you can have 3 plots. Well, so you can have 9 plots on one figure. If you want here, I'm just doing 2. So I'm doing a distribution plot and a bar plot of the sepal data. I'm setting the axis of for the one plot and axis of the other plot. And if I just plot that, we go to figure, you see about 2 plots on one figure, right? So that's one question somebody asked. And then another question was, just about high dimensional and multivariate data. So again, if you can use the Irish dataset as well. It's multi-dimensional, multivariate. And also this is also an example of plotting multiple figures on one plot. So this is using a pair plot. So this is a built-in feature of Seaborn to have 9 figures. Actually more, actually it's 16. So it's 16 plots. But this shows an example of how you plot multivariate data as well. So that's a few questions. So this is a bit of visualization. So again, this should be quite straightforward. There's nothing too complex about it. Again, if you want to do multiplots, you just use the subplots, and that's for most plotting libraries. You have some kind of a subplot function. The rest isn't too difficult to understand. Extracting features from different data sets using unique ID and using apply functions is another question. So I think this was extracting features. So for example, this is what a bit of what we covered before, but maybe a different way of using it. So suppose we have 2 data sets, orders and customers. The orders data set contains information about orders placed by their customers, including the customer ID. The customer data set has information about the customer, including the customer ID. So our goal is to extract the features from both data sets, combine them into a single data frame based on customer ID. We can use the apply function to create a new column to the orders data set, right? So how to do that? So if you want to have a look at the data quickly, if you go to files and orders, this is what orders look like, just 10 rows of data with the name and the order, product and quantity and price, customer information as well, just some random data. So the common column is customer ID. So you can see customer ID. So what we're going to do is we're going to join them, or we're going to merge them. So we're going to merge them. So the one way you can define a function to do that, and then use apply. Use apply because obviously apply allows you to do any kind of calculation on an entire column of data, and then this just stores it, in a new column. So this is one way to do it. If you want to use apply, I showed you apply last week. A bit easier way is just to use merge. Well, what you can do is just merge the two. So we know the 2 CSVs are, well, 2 data frames is orders and customers, and we are merging it based on customer ID. And then all we do is we're going to extract the name from that data set, or from this data frame. We're just extracting name and putting it a new data frame, a new column in the orders data frame. So this is 2 ways to do it. If you have a common column called customer ID, you can extract that information and put it in a new data frame. So that's how you can do that. Again, the second way is a bit easier, just using merge. The first option, what the person asked for, was using apply, where I'm just extracting that customer ID information, getting the name and applying it to the column. So apply is quite useful because you can apply any kind of function, any calculation you want to any row, sorry, in any column, and then you can designate it as a new column. Another example would just be if I wanted to, if the price here was 50, I can maybe convert that to the dollar. I can do like a currency conversion. So I would use apply on this column, on this price column, and then multiply by the conversion rate, and then create a new column, say like price in USD, for example. So that's where apply becomes quite useful to use. All right, so that was that question. And then high dimensional did that, extracting feature did that. How to display all rows of a data frame that has 1,000 rows. So you can set the display max rows to 1,000 if you want, or you can also convert the data frame to a string and then print that out. So this is two different ways. Another question about application of pandas in machine learning, if any. Well, obviously, it's a key tool for machine learning to do an EDA, exploratory data analysis, some pre-processing, data integration, merging, transformation of data. So it's obviously a key tool for machine learning. In terms of applications, well, it's really any application. It's just, it's a tool for handling data, right? So that's really what pandas is useful. Another question is about image processing. So I work with large video files, many frames, and to save data from each frame in an efficient way, planning on using pandas data frames. Another way could be 3D arrays. So again, what kind of data are you extracting is a question. And I'm assuming you are using OpenCV because that is the go-to tool for any kind of computer vision or image processing. So I'm assuming you are using OpenCV. And you can do this like if you've extracted your information from a single image, you can, each video might have its a video index, and subsequently an image might have its own image index, and then each image might store its corresponding feature or information. So obviously you can do that, but again, it's just a table of data. You should never really use pandas to actually store images because it's not designed for that. I mean, you can theoretically store the pixel values, RGB values as a data frame, but it's not what pandas is designed for. All right, so that was data visualization, the question. And then there was a question about EDA, so which I think is quite useful. Person asked for like basic steps for EDA, so which is what we covered to some degree. But if we're using Python, I mean, Pandas is a go-to tool for such things. You typically read in your data, explore the data, maybe using a profiling tool, or using the built-in Pandas tool, just explore the data, get a feel of how it looks like. Very importantly is cleaning the data, removing like any missing or null values, removing duplicates, handling outliers and anomalies, handling categorical variables, encoding them, and analyzing the data as well. And also when you want to, when you do calculations on things, it's better to first group the data if you have a large data set. So using group by and then doing aggregation like mean, or if you have your own aggregation algorithm, you can do that. Sorting and filtering, all part of EDA, visualize the data, draw conclusions, and then also notice this is a iterative process. So you might see things, you might need to redo the EDA. Once you've cleaned the data, you might get certain other insights. So this is, again, all these notes are on GitHub, so you can access it, but I think it was a useful question. So hopefully this kind of summarizes it. And then there's quite a nice link that that discusses, well, it's like infographic of what for EDA. I'm not sure if it is actually here. This infograph just gives you a bit of a cheat sheet for, some basic functionality, loading data files, converting, transporting data, sorting, creating plots, frequency tables. This website NITheCS video is actually quite nice. I referenced it quite a few times, so quite a nice site, merging and joining. So again, this is on the website. Okay, that was EDA. Okay, those are features. And then merge time data sets. Okay, this was another question. This was more for merging data. So how does one combine two sets of data that is in a date time format? The one starting sooner than the second, and might be some overlap. How does one combine this without creating duplicates, or we have to combine and deal with the duplicates thereafter? That is, as a larger, avoiding this would be preferable. So there are many ways to do this. So I created two dummy sets that have a date time column and a value column, very generic. And I created an overlap as well. So for example, this starts at the 5th of January, and then in the middle there's a 5th here as well. So there will be an overlap of the data, and you can see there'll be a duplicate because this value and this value and this value is also the same. So there will be a duplicate over there for, I think it's this one and this one. So the 5th and the 7th is a duplicate, the same value in the same field. So how to deal with duplicates in that case, and obviously merging data in this way. So important that the columns should have a common column between them. So I use the merge function, and because we have two data sets, it's important to use the outer parameter, which is like a full join, so you can get both data sets without removing any data. We discussed merging and the different types of joining last week. And then you can also remove duplicates, right? So how does it work? So quite straightforward. You read in the two data sets. We merge it to data frames with a full outer join. So that includes all the rows. And then we're going to drop the duplicates. So we first check, we can create a variable or a series actually that's a mask that just checks for when the value in value 1 column and value 2 are not the same. If you filter the data in your in a new data frame, and then you drop any duplicates. So how's that look? So if you run that, let's look at the variable explorer. So we have our two data frames. These are two data frames. And then when we merged it, this is what merge looked like. So we still keep both. We're keeping, because it's an outer join, we're keeping all the data. And then we can see here is a duplicate, and here is a duplicate. So for example, if you want to remove it, you can. So I did that with merge df drop delta loop. So here you can see that there's duplicates. So the 5th and the 7th were removed, and how you want to deal with that, with the the other ones, it's up to you. But that's an example of how you merge the data, and obviously drop duplicates, right? So there's pros. It's an open-ended question, like what you want to do with the data, but this is just showing you how to merge them. Okay, that's merging. Okay, Nima, you can go on the NITheCS website to see there's a question about the previous class recordings on the NITheCS YouTube website. Maybe someone can just put it in the chat. the NITheCS YouTube website. Somebody asked about that now. So yeah, okay, so that's the data set, that's customers, and yeah. So another question was using a large data set. So how to be mindful of optimized code, how to avoid redundant code, what are computational intensive, costly functions to be aware of. So when working with large data sets, you have to obviously be mindful of performance of your code. There's quite a few things I mentioned, considering using different types of variables to reduce memory, using chunking, which reads in chunks of data instead of the entire one. And then you can also, with read CSV or reading in files, you can also you can specify how many rows you want to read. So this helps just kind of reduce the memory usage. You can have vectorized operations. Apply method is quite costly. Well, it's useful, but to apply that to a data set can be quite computationally expensive. So in this case, use a group by first filter, and then you can use your, do aggregation or apply certain functions. Indexing, speeds up operation. I say group by, using group by aggregation instead of apply. It's preferable. Avoid redundant calculations. There's actually one thing I forgot to mention here, which is for loops. Try to avoid for loops. They are computationally inefficient and slow down processing. Rather try and use built-in methods and functions, to do such things. Yeah, so other things is like obviously parallel processing. If you have very large data sets that goes into like terabytes, for example, or less, you have to obviously do parallel processing. We have not just one machine you're working, but a cluster. So you have multiple machines. You can process your data, or do loading, pre-processing, and post-processing as well. So there are tools for that. I go into a bit more depth, but I won't explain it here. You can read through it. One useful tool, if you do have large data, is, or one useful library is called DASK. I think it is mentioned somewhere here. And there's the Pandas has very good guidelines on large data operations. So briefly, try to load less data, for example. So you can read in, if you use chunking is one way to do that. So you can use columns, only limit the amount of columns, the amount of rows you're actually going to read in. Use efficient data types as well. So for example, yeah, they're going to depth into like how to categorize your variables to make it more efficient to read it in. Using chunking, you can read through that, but quite useful. Here they're using other libraries. So Dask is primarily for parallel computing. It's very similar to Pandas. You'll see the similar functionality, like reading in data. So it's something to look at. But all these links are on the site, so you can have a look at it. Yeah, so that's all the questions I'm going to cover. I think they covered some of the content as well I wanted to discuss. The next thing we're going to cover is time series analysis as one of the topics for the mini school. So before I continue, I just want to put the form on the chat. So you can maybe start completing the form. Any questions or comments you have, any examples you want to see, you can fill in this form. It's similar to forms previously that we've done, but just gives you a bit of insight into what you're looking at for the mini school. Remember, we have one more lecture next week, so I can try to cover some of your questions there. And again, you also have the GitHub discussions forum, so if you want to contact me there, you can. So any questions or comments? So I'm going to take it like a 2-minute breather. If there are any questions or comments of what we covered recently, you can say in the chat. Maybe we can get a thumbs up if everybody's, everybody follows. And if anybody is alive there on the other side of Zoom. So maybe a thumbs up somewhere. Okay, so I'm not alone. Yeah, so please fill in the form. Please fill in the form as well. It gives me an idea of what you want to cover still. We have one more lecture next week. We're going to do time series analysis and a bit of stats as well. So I'll just wait another minute or so before we continue. Again, any questions or comments based on what we covered so far? I'll wait in the chat for 30 seconds. I see people are responding on the form. Okay, so I see a lot of people are filling in the form, which is good to see. Using pandas for spectral data peak integration. If you can give me, I'm not sure who said that, but if you can put that in the discussions and GitHub, if you can give me examples of what you're looking for, then we can, maybe look at it next week. All right, so yeah, please fill in the form. Any more questions or comments? Okay, more people are filling in. Okay. Okay, so while you're filling in the form, I'm going to carry on with the time series analysis. So up to this point, the iris datasets, was that a time series dataset or not? The iris dataset was a time series or not? Respond in the chat, was that time series or not? Mazwandile, what do you, please do you, I'm not sure what you mean by your comment, Mazwandile. Yeah, so obviously the iris dataset is not, time dependent. So I can't really use that as an example. So what we're going to look at first off is the pandas, user guide. And if I open my, I don't do that anymore. It's going to be, yep. So this is the pandas user guide. And again, if you really want to master pandas, this is the first place you need to really go through and look at all the different features and functionality of pandas and what it can do, which is quite vast. So overview of what it covers is looking at timestamps versus time spans, converting to timestamps. Sometimes you have data in the wrong format. Maybe the format wasn't input correctly, or the format is just what you're expecting. So converting that to a timestamp is quite important to do your analysis. Generating a range of timestamps, timestamp limitations, indexing. Most times, if you want to do a plot, you want to see your timestamp or timestamps on or your date time on your x-axis. So you most likely would set that as your index. So I'll discuss the indexing, time data components, resampling. Sometimes you have missing data, missing timestamps. So how do you kind of resample the data to fold that in? Time span representation, conversion between representations, time zone handling. So yeah, there's a lot of content here to go over, so I definitely recommend going over it. There are a few the tutorials that are also quite nice. Again, I look at what was in this one? It was time series analysis and forecasting by NITheCS video. Really like how they do the tutorials and break it down. Okay, somebody's asking about GitHub, about the code. Yeah, so Takale, so just go to GitHub. Here's a link, and then you can get all the notes and lectures up to this point. Right, so yeah, so I have this link here, so you can have a look at it. So it goes through quite a bit of details about what you can and cannot do for time series and analysis. So I won't go through all of this. You can go through it, looking at the significance of time series, different types of results you might look for, forecasting, segmentation, classification, components of time series analysis, trend, seasonality, cyclical, irregular. Yeah, there's many features you can look at, testing for if it's stationary or not, mean variance, covariance, so stationarity, doing some statistical tests. So we will be covering most of this today. I'm just giving you a brief overview of what they did in this lesson. So it's also a good reference to go over. So it should give a good idea what you can do in Pandas and various functionality, autocorrelation. I think they also do, I think forecasting as well, a little bit lower down. But quite a nice tutorial to go over. I think, oh, they also a brief example of recurrent neural networks. So there's this link, and then also this one as well. So an NITheCS video, they don't cover resampling or window or frequencies, which is an important concept. So I just put that there too, just so you have a link, just to know what you can do. So have a look at those two links, and obviously your Pandas site as well. All right, so what we're going to do is we're going to look at a example, a data set, and we're going to just work through some of the basic functionality, time series analysis. So you get many different types of time series data. So I mean, I'm going to be looking at a weather data set. There's various others, geographical, stock market analysis, and many others. Weather's kind of the easiest to work with, so I chose that to work with. And we cover quite a lot of things you can do with TSA, or time series analysis for weather. Just look at any questions or comments that have come up. Can somebody just go to the YouTube, go to NITheCS and copy the link there, so people can access the videos. All right, so what does the data look like first? Let's have a look at the CSV. Let's go to files, go to weather. So we have an index column, which we'll just ignore, and then we have date time. So this is a format that is stored in a count. So I think this weather is just like the amount of vehicles in a certain city, for example, and then it covers like at a certain road or something, amount of vehicles that pass through it, and it covers the temperature and precipitation as well for each day. And yeah, so this is typically what the data set looks like. So what I'm doing here is Let me just move this over here. I'm going to read this in as a CSV, weather.csv, past dates. So this just informs Pandas that this is the format needs to be in a date time format. And then index column 0. This will just allow you to ignore that index, the CSV file's index. If you don't have this, then you'll see it as an unnamed 0 column, which is very useful. And then here I'm setting the date time. I'm setting date time as the index because we're going to, when we do plots and whatnot, we're going to want the date time on the x-axis. And I'm just doing a copy of this data frame just to show you a quick side example of, sometimes you want to split the day you have into month, day of the week, and day itself. I just want to extract certain more information. If you want to look at maybe trends or seasonality, you can also do that using Pandas built-in function as well. So, and then create a new column for month, day of the week, and end day. So just an extra feature if you want to not to do that. So what else are we going to do? So first thing we do is we first do an EDA just to get familiar with the data. So what I've done is first going to inspect the data. So how do we do that? So I'm sure you're used to my profile reporting. So what I did was I actually created a separate file that does it for me instead of putting it here. So it's actually a module that I created. And all I do is I give it a data frame. I pass it to this function in this file. And here the file's name is run profile report. So if we go to run profile report, all it does is it accepts in a data frame, does that profile reporting stuff, and then opens a Firefox tab that has a profile report. So let's see how we'll see how it works shortly. Okay, so that's going to do our EDA. Again, you can do your own manual ones just to do a head info, describe things that are quite common. And then we're going to visualize the data, do like just do a line plot, just see what the data looks like, temperature and precipitation. And then we can look at, do some stats on it. So there's a well-known Python library called stats model, which decomposes the data into trend, seasonality, and residuals. So I'm going to show you that. So you're just using this function. You input your column that you want and your various parameters, and it gives you different plots, checks for seasonality, trend, and residuals. Again, using stats models, you can do autocorrelation and stationarity tests as well. And you can also, using stats models, you can do time series forecasting. So whichever forecasting model you want to use. Here, I'm just using a REMA, very generic, not something I really went to depth with, just to show you what you can do, right? So ultimately, it just predicts 10 or actually 12 days into the future. All right, so that's typically what the code does. So let's just run it and see what we get. So the first thing is going to be the EDA, or the profile reporting. So it's going to run, and then it pops up the data set. So we can see it's mainly 3 numerical values. So you can maybe have a categorical value that says maybe gives you a value like it's hot, cold, warm, those kinds of categorical features. You can have various other fields as well. 304 observations, so quite a small data set. No duplicates or missing cells. So count again, this is just the amount of vehicles at a certain road captured. This is the temperature, precipitation, looking at interactions. So okay, this is just some interactions of the data that that you can look at. Some correlations as well. You can see different, wait, where's my correlation? You can see certain things that are correlated and not, and the sample data as well, right? So just a quick EDA, instead of doing everything manually, you can, I quite like profile reporting, so I use it. So that gives us the EDA. And then what we did was, okay, that's that one done. And then we can visualize the data. So I think there should be a plot over here. Bit of plots. I think our first one, yeah. So this is what the data looks like. So you can also plot this, you know, if you want to, you can save it, you can save an image, and you can, you know, make this a separate window, for example, if you want. Here I'm just plotting it inside. I mean, so this is typically what the temperature data looks like. Temperature over a year's period, and the precipitation as well, just to give you an idea of how the temperature changes. So that's that one plot over there, and then we have seasonality, right? So then we're checking further for yeah. So this is the looking for trend, seasonality. So there is some trend you can see, and any residuals or noise. So you can see there is some trend in the data set. This is for the temperature column. We're going to look at the count as well. There's some seasonality as well, some patterns that you can see in the data. And then I think the next one is autocorrelation, partial correlation, and then the last one is a forecast of the data. So just forecasting, you know, a few days in the future, what would the temperature be? So one thing I'm going to change here is just the I want to look at I think it was this one. I just look at, I have to look at count, maybe leave that over there, but count, and then count here and count there. Don't need that anymore. All right, so let's look at, all right, so this is our count data. So this just shows the amount of vehicles at a certain a point of time at I think at a road somewhere in a city. And you can see there's some kind of a pattern even from the raw data. So you can see that there's a trend in the analysis that's done, and some seasonality as well, and some residuals or noise that you can probably remove afterwards. But yeah, so you know, easy just to save this as a image. But I mean, I think you kind of get the idea about that. Well, you like, and can we edit the display of the x-axis to make it vertical? Yes, you can. You can rotate it to any angle or degree that you want, so that you can do that. That's fine. So yes, and I think the last one was, this is autocorrelation for the, okay, and this is actually still the same one. This is observe and forecast. Yeah, this is all the same. But yes, so that's a bit of what you can do for time series analysis. Again, if you have any questions or comments or certain things you'd like to see done, you can let me know. You can post questions or comments in the chat as well. Yes, any questions or comments, you can, you know, post in the chat or on the form. So please also fill in the form, gives me an idea of what you want to see. And also you have the discussion. So there's about 7 minutes left. So I'm going to end it there. Again, any questions or comments, ask in the chat, and I'll just wait for any feedback.
Yeah, Benjamin, maybe while the participants think about feedback and questions, thank you very much on behalf of everyone, again, for a very interesting session. Sorry. I don't see at the moment any so the recording is online, yeah, and we will post this one online as well very soon. Okay, Benjamin, if there is no more question, then maybe we can stop here for today. And I know that the participants are very active in sharing their question with you in between lectures. So I'm sure by the beginning of next week, yeah, it's the last lecture next week, we will have a few questions to follow up. Yeah. So again, thank you very much, Benjamin. It was again very interesting. And thank you to all the...
There was a question on...
okay, just popped up. Yeah,
on
please,
school.
Benjamin, if you want to answer it, yeah.
Like what data school are you referring to? The feedback. And just a quick, but I can also, I mean, if you want to rotate your labels to make it vertical, you can just say vertical. You can also make it certain angles that like 45 degrees or something. That's your one question you had. And then the Code Data RDA school. I'm not sure about that, Prof. Do you know about the Code Data RDA school?
To be honest, no. I know that takes place every year, but I'm not sure when the next one is. But I'm sure they have a website where one can find out. I don't know.
Yeah, we're not part of that. So, yeah, we're not part of it.
I think it's a yearly event, so I'm sure one can find out. Yeah.
Kale is a data 2D. So which data are you referring to? And do you need to merge .nc files in order to plot multiple variables in one plot? So again, if you have examples, post it on the GitHub discussions. You can put CSV and images. So it's difficult to understand what you mean there. So if you have actual data, you can post it on the GitHub discussions. I can try and answer your question next week.
Yeah. Okay, then thank you very much, Benjamin. Then maybe this is the natural end of today's lecture. So thank you very much, everyone. Thank you, Benjamin. We will, as I mentioned before, we will upload the video again on our YouTube channel. And I'm looking forward to see you all next week again at the same time in the same Zoom link. Yeah. So Benjamin, thank you very much. Thank you very much. We stay in touch. Thank you. All the best and lots of compliments popping up.
Thank you. Thank you.
Well done. Well done. Excellent.
Okay. All right. Bye.